All right, welcome back, everybody. Big announcement today. Everybody watching along at home. I want to thank all my fans, thank all my people that support me. I couldn't get here without all of your support and help. But a big announcement here. I got 200 subscribers.
Where's your giveaway? Are you doing a giveaway?
Should I do a giveaway?
Yeah, or a special.
Now, how do I can't tell who has subscribed. Like, I can't see my subscribers. But how do you see it? I guess maybe that's my next question. How do you see who has subscribed?
Google it right now.
People comment.
Yeah.
Okay.
Or you could just have kids show you if they are or not.
Yeah, I can show you.
I guess that's true.
But he's famous, so there's gonna be too many.
I know. I got 200 subscribers.
Yeah, that's 200 people. That's a lot of people.
I mean, that's a lot of people. I got old students watching my videos. I got new. I got random people on the internet watching my videos.
You come up sometimes. Yeah, I mean you're famous.
Henry's gonna unsubscribe. No, don't do that, Henry.
All of the accounts.
How many accounts do you subscribe with?
Like 4.
It
I'll
doesn't matter. He
subscribe
gets
back
one
with
view
my
per
like
video.
account.
Oh my
God.
He's getting 1 penny. Henry's a straight.
1 view, 4 views, 4 views, 1 view, 4 views, 2 views.
Like Mr. Lavin, when I refresh my feed, sometimes you come up. Like you're just famous.
I mean,
that doesn't mean I watch
Yes,
it,
Sid.
but
Look, you're on that feed. Look, right here.
see, I'm a
Calculus section 4 through 3, day 1.
4, 3, day 1, 11, 111, 22. That was yesterday's notes. Hey, think about it this way. If you guys want to learn calculus, you just watch my
I
videos.
don't want
I'm taking trigonometry
to.
that
It's
year.
nice to be offered.
All right. What's my picture? That's me right there, 2 years ago.
Yeah, too.
That's Jake Trent in the background. I think he's
That's like a
senior.
girl.
What's that?
That's like a girl.
He's got long hair.
I can't even
Yeah,
see.
Jake Trent's got long hair. Yeah, that's that. He sat right over there. Yeah. Do I need a new picture? Yeah, I'll try to get a new picture. All right. So again, thanks everybody for all your support. Let's see if anybody unsubscribed. Do I have under? Oh no, still 200. I'm still good.
Hey,
Oh.
It's not done refreshing.
Hey, 202.
Oh my God.
You're
Let's
also
go. Let's go.
I'll
All right.
subscribe right now.
I'm good.
Do you have a subscriber generator?
Yeah. All right. Now, I'm going to go back and restart this. I accidentally started this problem without doing the video. Ella said so wisely here that the negative exponent shifts it down into the denominator. She's like, okay, yeah, you put it down there. Now, so that's what we have here. Now, somebody said first period, well, couldn't we have distributed this in?
I made it like 1,000.
Yeah, and now I'll have to do that. But at this point, I think you guys are starting to realize there's kind of different ways that we could do each problem. There's different routes to take. I am going to keep showing you the easiest route to take, in my opinion, the easiest. Now, what do I do with this 3? That's where it gets distributed in. So you can either distribute it ahead of time and then shift everything downward, or shift downward and then distribute. Doesn't matter. 1 over, this is 10 to the third, y to the third. And that's the property that we learned yesterday, that distributive property there, where we're going to distribute each piece to each piece the power. And then, I do have to make that 10 to the third power. Remember, any power of 10 is just 1 with that many zeros after it. So if it's 10 to the third, it's 1 with 3 zeros after it, and then y to the third. All right, second problem here. If I have this quotient, this is this rule here. If I have this quotient, what do I do with the power?
You give it to both of them.
Yeah, basically distribute again. But instead of a product like we had in number 1, now we have a quotient here. So this is going to be a 1 to the 5th, a 2 to the 5th, and then, Gio, what's my power going to be on k? K to the what?
The second.
But I have to take it to the 5th power.
Oh, 10.
10. Yeah, because this is like k squared to the 5th, which that's another power to a power. That's I multiply. And at this point, I just have to evaluate. 1 to the 5th is 1. 2 to the 5th is 32. And then we've got k to the 10th. All right, last one here. Nick, that negative exponent on that fraction, this negative exponent on this fraction here, tells me to do what with the fraction? Flip it around. Yeah. I have to flip the fraction. So now this becomes 7 over 6c, all raised to the positive second power. And now I use that quotient rule where I distribute in. So that's like saying 7 squared over 6 squared, c squared. And I take my powers, 49, 36, c squared. Okay. Questions about those three? Again, I can't stress it enough. You know, I know you guys are going to have your calculators with you, and you know, it's pretty easy to punch numbers in. I would say you guys should have in your brains the powers at least up to 10, like squared powers up to 10, perfect squares up to 10, like 1 squared, 2 squared, 3 squared, 4 squared. So 1, 4, 9, 16, 25, 36, 49, and so on. Yeah, 8 is 64, 9 is 81, 10 is 100. That should be in your brain. Like 7 squared, 49, easy. 6 squared, 36, easy. My Algebra 1 teacher way back in the day, shout out Mr. Rigler, shout out. So my Algebra 1 teacher back in the day had us memorize up to 20. Had us memorize up to 20. Like we had to take a times test. Like it was, and he did it once a week. Where on Mondays you had to like just write out the powers, squared powers up to 20. You had 1 minute to do it. 121, 144, 169, 196, 225, 289. See, that's where it starts to get fuzzy. Oh no, it's 256, 289. That's 17. 18 is 324. 19 is and then a 1. Let's say 351, and then 20 is 400. I think. Those might be off a little bit.
They're right. I remember 196.
196, yeah. So again, I think it might be a good idea to at least have perfect squares just up to 10 in your brain. Okay? Not something I'm going to test you on. All right. What questions do we have on the homework? What questions do we have on the homework? Yeah. Number 40, last one. All right, so if I'm looking at number 40 here, I've got 1 over 2r to the 6th to the negative 6th power. Okay, negative exponent on a fraction flips the fraction. 2r to the 6th over 1 to the 6th power. Now, do I need this over 1? I don't really need that, right? So what I'm going to do is I'm just going to kind of erase that right away, just so I don't have to worry about it. Now let's bring this in. So that's 2 to the 6th. Now be careful. Don't make that 12. That is not 12. That is 2 to the 6th. And then we have r. Okay, now what is the power on r? 36. Multiply. All right, and then 2 to the 6th. Remember, powers of 2 are just doubling. So like 2 to the 2nd is 4. 2 to the 3rd is 8. 16. 32. 64. So 2 to the 6th is 64. R to the 36th. Yes, sir.
Can we go over number 26?
Yeah. Any other questions on 40? 26, you said?
Yes, please.
Okay. Let's take a look at 26. Move this out of the way. Yes, you did. 10 to 28. Okay, so 26. Now, what's my power on this negative 7? Oh, wait a sec. Oh, no. That's okay. Because you could consider this a negative 7 to the first power. What? Why? Anything without an exponent, you consider to the first power. Right? Like if there's just an x sitting there, what's the power on x? 1. So if there's a negative 7 sitting there, what's the power on negative 7? 1. So like basis, what do I do if I'm multiplying with like basis? You add. 1 plus negative 4 is negative 3. So this is 1 over negative 7 to the positive third power. Got to shift down because it's a negative exponent. And then I'm just going to go to my calculator and say negative 7 to the third power, which is 343. Net 1 over negative 343. sense?
Yeah, thank you.
Yes.
Can you go to
20. Yep. Same type of thing there. The base is -6. What do I do with my exponents when I'm dividing? Subtract. 8 minus 5 is 3. And so now we just have to take -6 to the third power, which is -216. Make sense? Yeah. 36? Yeah. Let's take a look at 36. Okay, same type of thing there. Take that third power and distribute it in. So, whoa, that's 38. Math teacher doesn't know his numbers. 36. Okay, there we go. Same type of thing there for a quotient. Bring it in. So this is -t squared over 3 squared. So now, -t squared, be careful with that. When I square a negative, what happens to the negative? It goes away. So this has to be a +t squared over 9. Is that what I had on the key? Make sense? Anything else on the homework before we get to the notes that we need to pick up? Yes?
Can we do 18 really quick?
Yep.
Thank you.
Doesn't even need to be really quick. Oh, that one's a good one. That one's a good one. Because there's a lot going on there. Remember, these are one of the problems where we're like, okay, is it happy or not? Look for a negative exponent. Is 13 happy? Be careful, everybody. Look at the problem. Luca. You need to do your homework, Luca. People throwing things at you, Noah.
I can't throw it. I'm too close to him. It wouldn't be a throw. It'd be a handoff. And I didn't hand.
Don't try to make excuses. Is 13 happy?
Yes.
Yes. The x is what's being raised to the negative exponent. So leave 13 on the top. The x shifts down. The y, what happens to my y to the 0? It cancels out. It goes away. It becomes a 1. 5, not happy. Goes up to the top. Z, not happy. Goes up to the top. All right. Now, I just have to go in and actually do that. 13 times 5 to the third. 5 to the third is 125. So a total of 1625. Z to the 10th over x to the 5th. Okay, if you wouldn't mind getting out yesterday's guided notes, we have to do a couple of the problems. That didn't do. We gotta do this one, right? Yeah. We did not do example C. Yeah, you need it. Right? We did not do example C on letter C on example 3. So we're on the back. Okay. Now, if you're watching from another class, some of my other classes we got to this one. So if you're watching from another class and you say, oh, I already did that one, that's fine. Okay. But we're looking at example C on letter C on example 3 on the back. All right. So first things first. I have to work with the negative exponent on each of these fractions. Now, what does a negative exponent on a fraction tell me to do to that fraction? Anna? Flip it. Let's flip it. 3 over 2. 2n over 6m to the positive third power. Now, I am actually going to reduce a little bit here. I'm going to encourage you to try to reduce before you start moving any power. So before you start taking any powers. Because if you don't reduce, things might get out of hand kind of quick because we saw yesterday, numbers get really big really quick with exponents. Is there something that I can reduce?
1/3. Or like 6 to or 2 6 to 1/3.
Good. Yeah, what he's talking about here is this fraction. Everybody look right there. That 2/6. I can reduce that. So let's do it. I'm going to leave everything else the same just so I don't confuse you. 3 over 2 squared times, okay, so now 2 over 6 is 1 over 3, right? I don't really need to write the 1 on top, though. So n over 3m, all raised to the positive third power. Like, I could put 1n on the top if I really wanted to, but you don't need to. Yeah.
How come we can reduce when 2 to the third power is different from 1 to the third power?
Because on the bottom would be raising by that same power, which would then reduce in the end.
Oh.
It would reduce back out in the end. See, there's choices here that we can make. If we don't reduce now, we'll have to reduce later. Because the power is only going to increase that power, that number that we would reduce by. Like here, we just divided by each top and bottom by 2, right?
Yeah.
Later on, if we were to try to do that later, we would have to reduce by a power of 8, 2 to the third power.
So you're just doing it now.
So I'm just doing it now before our numbers get too big.
Okay. All right.
All right, now let's bring in the exponents. 3 squared over 2 squared. N to the third, 3 to the third, m to the third. Now I'm going to do something a little bit funky here as well.
Your Bitmoji looks exactly like you actually.
No,
Just
actually,
roll your, if you had your sleeves rolled up.
I know I should.
no, it looks
That's okay.
exactly like.
Look, we're mid-problem, folks. If you could just, buckle down and...
Yeah, you got me.
Yeah. Now, in terms of a fraction here, I am not going to start evaluating these numbers just quite yet, because in terms of a fraction, remember that if I'm multiplying, I don't need common denominators. I can just multiply straight across on top and then straight across on bottom.
How did n over 3m come from 6m over 2n?
Okay, so we flipped it because of the negative exponent. Okay.
Yeah, like you can like flip it, but like. I don't
And
know
then how
you
did it
got 3
reduce?
to- How'd you get like 3 and just?
We took 2 over 6 and reduced it down to 1/3. So this 2 over 6 turned into 1 over 3. Like I can write a 1 in there if I really wanted to, but it's not going to change anything. Okay? So that became this. Okay. And now we just distributed the power. Now, everybody watch what I'm going to do here. Just going to put everything in the numerator and then everything in the denominator. I know I can take 3 to the third or 3 to the second and 2 to the second and 3 to the third. But the reason I'm not going to do that yet is because there's something else I can simplify now. Exactly. I can take these and simplify them. 3 to the second over 3 to the third. Be careful.
Oh.
Subtract.
So,
Subtract. So this actually becomes 3 to the negative 1, n to the third, 2 squared, m to the third.
I feel like whenever I get on my own, I like blank out.
Well, this is a difficult problem. This one is a lot of steps. All right, now let's finish it off. Is the 3 happy?
No.
Down. So n is happy. 2 squared, I can make that a 4 now. The 3 comes down. M to the third. And then I just have to finish this off to take 12. M to the third. Yeah, I would say by far this is the hardest one that we had done. That's why I wanted to catch this problem. Yes.
I missed the part about where like the 3 went and stuff.
Yeah. So this is like basis we subtract exponents.
Right.
So what I can do here is say, well, 3 squared over 3 to the third, 2 minus 3 would be negative 1, right?
Okay.
That's why you see the 3 to the negative 1.
Uh-huh.
Then, since it goes down to the denominator, 3 to the positive first would be down there.
Oh.
Yeah? Because it's not happy on top, so it goes down to the bottom.
Okay.
And then I just made that 2 squared 4, so in the end it had to become 12.
Okay.
That's a tricky one. That is a really tricky one. And again, I could have done that problem vastly different right from the beginning. Right? I could have distributed all of those powers right away if I really wanted to. Yeah, Jim.
How did the 3 have like a negative exponent after it had positive exponent?
Right. So the 3 square. Remember, I'm subtracting, right?
Subtracting what?
Subtracting the exponents. When I'm dividing with the bases, right? When I'm dividing with the bases.
When do we start dividing and then subtracting?
Okay, so because I got the fraction bar, right? So if I've got one on top and one on bottom, I do top power minus bottom power. If you've got the same base of 3, I can do top power minus bottom power. So 2 minus 3, that's where I got the negative 1.
Why wouldn't you do 2 minus 2 since that one is right there?
Good question, because that's a base of 2, not a base of 3. The bases have to match for you to do the operations with them.
Only so
That's why we can't
it's
take
a fraction and it's over and it's got like the exact same
base.
base.
Then
That's
you
when
can work with it.
subtract.
That's why we can't do anything to n and n in the end, because
just
they're
not the
different
same.
base. You can't do anything, Any other questions on that one? All right, let's take a look at example 4. Now, one of the best applications of powers and exponents is scientific notation. Now, I guarantee you guys have studied scientific notation in science classes, right? I'm sure. Probably at least some point in the past couple of years you've done scientific notation. Probably this year, I would venture to guess. Remember that scientific notation is basically one digit times 10 to the something, right? And it could be like 1.25 times 10 to the 8th. I'm going to have one non-zero digit before the decimal place, right? Positive powers mean really big numbers. Like 1.25 times 10 to the 8th power. That's a huge number, right? 1.25 times 10 to the 8th is a really big number. 6.25 times 10 to the negative 4th. That's a really small number. Negative exponents mean smaller numbers. So think about this. A jellyfish emits 1.25 times 10 to the 8th particles of light, or in other words, photons, in 6.25 times 10 to the negative 4th seconds. So it emits a lot in a really small amount of time, right? It emits a lot in a very small amount. What's wrong?
Don't get stoned.
So it says, how many photons does a jellyfish emit each second? Now, what's this asking me for? This is asking for the unit rate, right? This is asking me for the unit rate. The unit rate being photons per second. Particles of light per 1 second. So essentially, this is asking me to take 1.25 times 10 to the 8th photons and figure out per second 6.25 times 10 to the negative 4th per second. You may be thinking, how does this have anything to do with powers, properties of powers? Like, what in the world, how does that relate? Like, I get it. If these were simpler numbers, yeah, you could just take the amount divided by the time and get its per second rate, right? Just like you could take any speed versus time. Traveling, 80 miles in 3 hours, you can figure out your rate, right? Per 1 hour. Same type of thing. I've got photons per second. I can figure out my photon per second rate. Now, how does it relate to what we're doing now? Well, scientific notation is really just a power of 10, right? Take a look here. What I can do is kind of like section it off and say, well, I'm going to take 1.25 and divide it by 6.25, and then take 10 to the 8th and divide it by 10 to the negative 4th. How can I do that? Because it's just a product up top. Isn't that x in there a time symbol? So I can just basically divide like parts. So let's do that. What is 1.25 divided by 6.25? 1.25 divided by 6.25. 0.2. 0.2. What's going to be my power on 10?
4.
Be careful. I'm subtracting.
So it'd be 12.
It'd be 12. It would be 12. Why would it be 12? It would be 8 minus a negative 4. which turns it positive, right? We would say 8 minus a negative 4, and that turns positive, so 12.
How do we know that the parentheses?
Gio, look at the third one.
Well, honestly, you really just say 8 minus negative 4. You don't even have to put parentheses in your calculator. It'll just do it for you. Okay? So we got times 10 to the 12th power. Now, let me ask you. Is that in scientific notation?
No.
I mean, it looks like it might be, but is it truly in scientific notation?
No.
No.
You need a number where the 0 is on the left side of the.
I got to take this and put it there, don't I? Because there has to be one digit, one non-zero digit in front of the decimal. So this has to be 2.0 or just 2 times 10 to the. Now, does anybody know what I do to the power?
Make it 11.
Make it 11. Kick it down. Exactly. Your science teachers would be proud. You turn the you bring the power down because I made the number bigger. Basically, I said it's like a balance, right? I take 0.2 and I turn it into 2. I made that number bigger. And if I make this number bigger, then I got to make this number smaller. It's kind of like a balance. If I make this number bigger, I got to make that number smaller. Okay. So that's 2 times 10 to the 11th photons per second. I'm really sorry. I was going to give you a lot more time to work on your homework in class, but
It's all right.
it's all right.
It's all right. It's all right, you know.
But I'd like you to get started on this. Okay, you do have a little bit of time. You got 6 minutes, which is an eternity in a math class. So go ahead and start to work.
That's what I'm saying.
Text
You
each other
wants to be like me.
Text each other next
Like, you my kid, I swear. Every time I be like me.
You try to do it on me, man. You my kid.
Listen, I'm sing your kids to sleep. Because we're talking like every day. I'm like literally just like in your class. Like I was just asleep.
You know, I know I do have a soothing voice.
I don't even know if it's voice. It's just this.
You have a
Everyone,
soothing voice, I
not
guess.
obnoxious
No.
and like stupid. I mean, it's some of them, but
He just did
Hey, just be careful. The video is still playing. I'm still rolling here.
most of the people in this class, except for those who are.
Hey. Let's not throw stones here.